Today we are doing 6.5 day 2. We are going to use two new theorems that are very similar today. The irrational root theorem and the imaginary root theorem. Previously, we found irrational solutions or roots to quadratic equations. For example, we can find the solutions to x squared minus 4x minus 1 equals 0. It got really squished in there. Now this cannot factor, so when we couldn't factor, how did we find solutions to quadratics? The quadratic formula. Meaning we have to identify A, B, and C. What are A, B, and C? 1, -4, -1. It's a -1 on the very end for C. It kind of blends in with the edge of the board there. Okay, the quadratic formula, I'll write up at the top, is x equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. All right, we have to start plugging stuff in. So x equals, what is the opposite of b?
4.
A positive 4. Plus or minus the square root of, what is b squared? 16 minus 4 times a times c. All of that gets divided by 2 times a. If a is 1, 2 times 1 is 2. Questions about this so far? Should be familiar. Okay, so I'll go off to the side to keep going. 4 out in the front, plus or minus the square root of. Good. 16 plus 4. So a negative times a positive times a negative turns it positive. So this becomes 16 plus 4, which is 20. Can we simplify the square root of 20? Yes. What does it simplify to be? Okay, so we have 2 square root.
5.
Good. 2 square root 5 over 2. I know we're going through this quickly, but this isn't new. This should all be review. So we should be able to get through this quickly. To break down 20, you would break into 4 and 5. 4 breaks into a pair of 2s. That's how we got the 2 on the outside. The 5 stays in. The last thing we can do is simplify because 4, 2, and 2 are all divisible by 2. So for our final answer, we would get x equals 2 plus or minus 1 square root of 5 over 1. Of course, we don't have to write that. So how many solutions do we have here?
2.
2 of them. How do we know we've got 2? The plus or the minus. So this was our shorthand way of writing it all condensed. But the other way to write it would be that x is equal to 2 plus the square root of 5, and x is equal to 2 minus the square root of 5. Okay, so we have 2 different ways of writing our answer. Either smushed them together, or we can write them out separately. We have questions about that. That should all be review. But if we have questions, we should ask them now. Okay, are we all okay with the writing it out separately part? We see how that's the same thing? Okay. So let's move on. Let's keep this going. Number pairs of the form a plus the square root of b and a minus the square root of b are called conjugates. So on the last problem, you might be able to see that they had that form. We had 2 plus the square root of 5 and 2 minus the square root of 5. We would call these conjugates. It's like a definition. Do we get those blanks filled in? The a plus square root of b, a minus square root of b are conjugates. We're good there? Okay, it's just a new term. Has anybody heard that word before, conjugates? Okay. In a math class? You've heard it in English? Like to conjugate a verb, maybe in Spanish class? Okay. Okay, let's move on to the irrational root theorem, which uses conjugates. So you don't have to write this whole thing out. I think your notes pick up with the if a plus the square root of b is a solution. It should have an I in there. So this is, the beginning says let a and b be rational numbers and let the square root of b be an irrational number. Okay, that just kind of holds true all the time. So your notes should pick up with if a plus the square root of b is a root of a polynomial equation with rational coefficients, then the conjugate, which is a minus the square root of b, is also a root. Were we able to match that up with our blanks? Okay. In other words, irrational roots come in pairs. Irrational roots come in pairs. So if you know that a plus b is a root, then you can also assume or know that a minus b is a root. A plus b is a root. A minus b is a root. Okay, do we get those blanks filled in? Okay, we'll pause for a moment. Okay, on the first set of examples, we're given 2 roots and we are asked to find 2 more roots. Given 2 roots, asked to find 2 more roots. So the irrational root theorem said that irrational roots come in pairs. So think about the a plus square root of b, a minus the square root of b. So if 1 plus the square root of 3 is a root, its conjugate is also a root. What's the conjugate of 1 plus the square root of 3? We're focusing on the first root they gave us for now. We'll get to the negative square root of 11 in a minute. 1 minus the square root of 3. Okay, if 1 plus the square root of 3 is a root, so is 1 minus the square root of 3. Now the next one can be a little bit trickier. If negative square root of 11 is a root, we have to find its conjugate. Good, it would just be square root of 11. What number could we think about as being in front of this minus sign?
1.
Not a 1.
0.
A 0. So if 0 minus the square root of 11 is a root, then 0 plus the square root of 11 is a root. But we don't usually write the 0 out in front. That's why we don't see it there. Okay, but that's how, if it got negative root 11, then positive square root of 11 is also an answer. So now we've come up with 2 roots. That's what they asked us to do. That's it. Notice that on the 1 minus the square root of 3, you do not change the sign on the real rational part in the front. The A does not change signs. It was a positive 1 both times. Can anyone raise their hand and tell me what they think one of our other roots for number 2 is? Jacob?
Negative square root of 5.
Good. Negative square root of 5 would be the conjugate for that one. Emily, what about the other one?
2 plus square root of 7.
Good. 2 plus the square root of 7 is the conjugate for the first root they gave us. So those are our 2 additional roots. All right, very similarly, number pairs of the form a plus bi and a minus bi are called complex conjugates. Complex because they've got the imaginary part, the I. Now, while we're here, why don't we just do a quick refresher about I? What does I stand for or represent? Not just -1.
The square root.
Very good. The square root of -1. And I squared would be equal to -1. Okay, so if you don't remember that, I would maybe jot that in the margins of your notes, because we are going to need to be able to use that in a little bit here. Okay. All right, so let's do some examples with those. Oh, we'll do the imaginary root theorem first. So very similarly to the irrational root theorem, if the imaginary number a plus bi is a root of a polynomial equation with real coefficients, then its conjugate, a minus bi, is also a root. It is extremely similar to the irrational root theorem. Same thing happens with them coming in pairs. If a plus bi is a root, we know a minus bi is also a root. Questions, concerns? We get those blanks filled in? Okay, now I think we're ready for those examples. Again, we're given roots and we are asked to find 2 more roots. So we're still thinking about the conjugates. Okay, if 3 minus I is a root, so is 3 plus I. If 2i is a root, negative 2i is also a root. Okay, and we could use the 0 thing again. If this would be 0 plus 2i, this one would be 0 minus 2i. Any new volunteers want to give me one of the roots for 4? Sadia?
Negative 3i.
We've got negative 3i, so
sorry,
what's
positive 3i.
good? So its conjugate would be positive 3i. Anybody I haven't heard from yet today? Want to give me the last one? Charles?
Would it be negative 5 minus I?
Good. Negative 5 minus I would be the last one. Questions about finding conjugates? That's a good question. No. So the sign in the middle is the only one that changes. Kind of like up here. 3 minus I, 3 plus I. They were both positive 3s. It's the same thing. The real number in the front keeps its sign.
So where does that I equals square root of negative 1 come in?
We're going to use that on the next problems. Okay.
I was going to say, this is a little too easy.
Yes, I agree. It's a little too easy. Should we make it a little harder?
No, just keep it like this.
I wish we could. Okay. On the next examples, we are finding a third degree polynomial or a cubic polynomial equation with the given roots. Now, a third degree polynomial should have how many roots? 3. We've only got 2. Logan, what's the other one?
1 minus I.
Good. If they only gave us 2, we've got to think about what the third one would be. If it's a third degree polynomial, we should expect 3 roots. So the last root is going to be 1 minus I.
So we just write the opposite, like do the same thing we were doing in the last problem.
In order to find our last root. But now we are trying to write a polynomial equation. We have done this before, but when we've done it before, we've had all real rational roots, like 3. 3 is a real rational root. We would put it in parentheses with an x. Does anyone remember how we would write it? The x goes in the front. Should be plus 3 or minus 3? Minus. We use the opposite sign. So x minus 3 is one of our factors. To write our other factors, we've got to be a little bit careful.
1 minus.
We're going to have x minus
Square.
1 plus I. And we're going to have x minus 1 minus I. And this is the part you're not going to like. Okay? Now remember when we did these before, I usually multiplied which 2 together first? The last 2. We're going to do that still. Okay, so this is nothing really new. The steps are going to be the same. The work is going to be a bit uglier, basically. Okay? So I don't want you to think it's too hard. It's just a little bit different. Are we okay with how we set up our 3 factors? Okay, notice that I used double parentheses on the ones that had the i's. Okay. So when we distribute, we first take the x from here and we're going to distribute it to the x and the 1 minus I in the back. Okay, so this x gets distributed first. So yes, x times x, that one's not so bad. X squared. Okay, then we're going to have a positive times a negative. The x here is positive. The 1 minus I has a negative in front of it.
So negative x.
So negative x times 1 minus I. Does that make sense?
So we would just carry that.
Yep, we're multiplying it to the whole set of parentheses in the back, so we're just going to keep it in parentheses for now. Are we okay with that? Okay, then the next thing to do is going to be to take the 1 plus I, the minus 1 plus I, and distribute it into the back set of parentheses. So again, we've got a negative times a positive.
Negative
So negative x, and then in these parentheses is the 1 plus I. Okay, and then a negative times a negative is a positive, and we are taking 1 plus I times 1 minus I. What do you think we're going to have to do with the x's that are out in front of these little parentheses now?
Add them together and cancel them out.
What do we do with something in front of
Oh,
parentheses?
multiply by with.
Distribute it, multiply it in. Okay, so the x squared stays. Negative x times 1,
1x.
negative 1x. Negative x times negative I. So positive or negative?
Positive.
Positive. A negative times a negative is a positive xi. Now we've got negative x times 1.
Negative x.
negative x, and negative x
Negative xi.
times I is negative xi. Now we're not done just yet, but what is going to cancel out from what we've got?
The xi.
Okay, the xi's are going to cancel. Do you see that here? We've got a positive xi and a negative xi. Those are going to end up canceling out. Okay, if you want to go ahead and cross them off, you can. Those are going to cancel. But we're not done, because what are we going to have to do back here?
X minus.
Wait,
Cancel.
they cancel because it's negative and
No, because the parentheses up against parentheses means that we are doing what operation? Multiplying. So, we've got another binomial times a binomial.
Oh.
We've got to double distribute again. Okay, it's nothing new. It's just a lot of things thrown at us at once. So here, we've got 1 times 1
1.
is 1, so plus 1. 1 times negative I
Plus 1i. Or minus 1i.
is minus 1i. Now we're going to distribute the positive I in the back in. Ooh, forgot my I.
1.
Okay, so then I times 1
Plus 1.
plus 1
I.
I. And then we've got a positive times a negative.
It was negative.
Negative I squared. Okay. This is about to get cleaned up real nice. I understand this step, ugly. Okay, totally understand, very ugly. But if we do it right, then here on out it should clean up really nicely. What else is going to cancel out now?
The i's.
Good, the i's. The minus I and the plus I are also going to cancel each other out. What is I squared going to become?
1. Oh, negative. Wait, 1.
Okay, I squared becomes negative 1, but we're subtracting I squared. So subtracting a negative means we really end up
Positive.
adding. So I'm just going to write what I've got left. X squared minus x. That canceled. Another minus x. Got a plus 1. And then on the very end, we just talked about
Plus.
subtracting a negative.
Plus
We end up adding another 1. Do we see where all those things came from?
yes, where's x minus 3?
Okay. We have to now combine like terms. What gets combined? The x's and the 1's. So we've got x squared. Minus minus means we've got
2.
Minus x squared.
Negative 2.
negative 2x. Good. So minus 2x and then plus 1
Plus 2.
is plus 2. Now, you probably want to box that in and be done. But what have we not addressed
X
yet?
minus 3.
The x minus 3. Now, it's been a while since we've had to talk about that x minus 3. So when you get to this part, don't just stop. We now have to deal with the x minus 3. What's the other way I know that I'm not quite done if I see an x squared here?
X is in.
What do the directions say to find?
The 3rd.
A third degree polynomial. Do we have a third degree?
No.
Not
No,
yet.
2.
That's why we need to use the x minus 3. Now, before I create space to be able to do that, do we have questions about this step? Okay, we'll do another one together because this process is just a little time consuming. That's kind of how this lesson goes. This chapter, it seems. Okay, so I'm going to get rid of everything except for my new simplified quadratic. So now I need to take my x minus 3 and multiply it to the x squared minus 2x plus 2. This is something we've definitely done before. Okay, we are going to double distribute the x and the minus 3. First, we distribute the x.
X squared to the 3rd.
Cubed.
Good, so we've got x cubed. I'm going to write it over here to the right. So x times x squared is x cubed. X times negative 2x
To the
Negative 2x
squared.
is negative 2x squared. And x times 2
plus 2x.
is plus 2x. Now remember when I did these before, I didn't leave myself enough room here. When I did these before, I lined them up top to bottom. So when I move on and distribute my -3, I'm going to write it below the polynomial I just wrote. Do you remember that? So -3 times x squared
-3x squared.
is -3x squared, and I'll write it underneath the other x squared term. So -3x squared, -3 times -2x is plus 6x. And then I'm running myself out of room, but -3 times 2
-6.
is a -6. We are almost done. We just need to combine like terms. Anything to combine with x cubed?
No.
No.
Nope. X cubed. -2x squared minus 3x squared.
5x.
Minus 5x squared. Positive 2x, positive 6x.
Plus 8x.
Plus 8x. Anything to combine with the -6?
No.
No, so it comes down.
Are we done?
And then we're done. That is our third degree polynomial using all 3 roots. Number 6, same directions. We're finding a third degree polynomial from the given roots, but we notice that we are missing a root. If it's a third degree, we should have 3 roots. Good, our missing root is 2 plus I. So the first thing we do is set up our parentheses with x so that we have all of our roots. We should have 3 sets of parentheses. Tend to be writing way too big today. What goes in one set of parentheses? X plus 1. So it would be x minus -1. We write it as x plus 1. Okay, then we do x minus 2 minus I, x minus 2 minus I, and then x minus 2 plus I. Now when you see this, if you're tempted to get rid of some of these parentheses by distributing, I'm going to recommend you not do that. Technically there's a way where you can, but then you end up triple distributing instead of double distributing. We're much more familiar with double distributing, so let's keep it there. Now the x plus 1, we're just going to let that hang out for a minute. We're going to double distribute with the back sets. So x times x is x squared. X times -2 plus I. So -x
Plus I.
times, what's in those parentheses? 2 plus I. Okay, so don't break up these sets of parentheses yet. When we do this first double distribute, keep your parentheses together. All right, then we are going to take -2 minus I times x. A negative times a positive
Negative.
is a negative. We've got x, and then we've got those parentheses 2 minus I. In the very back, we have a negative times a negative,
Positive.
which is a positive. And then we've got both sets of parentheses. So 2 minus I and 2 plus I. Sorry, I'm writing a little small. Let me know if you can't see it, and I'll tell you what it says. Not very good at judging my space today. All right. This is when things start getting a little better. Okay, we still need to distribute the x's, but we know that when we start doing that, things will start canceling. So we have x squared, -x times 2.
2x.
-2x, -x times I.
2x. Negative minus x.
Okay.
Xi.
Minus xi, -x times 2, -2x, and -x times -I.
Plus xi.
It's plus xi. All right, in the very back, again, we have to double distribute. So this time we've got 2 times 2
4.
Plus 4.
plus 4, 2 times I
2i.
plus plus 2i. We've got negative I times 2,
Minus 2i.
minus 2i, and negative I times I.
I squared. Negative I squared.
Negative I squared. This is the part we like because a lot of it starts going away. What cancels out? The xi's and the 2i's. Negative xi, positive xi, those cancel. Positive 2i, negative 2i, those cancel. So let's rewrite what we've still got. We've got an x squared. We have a negative 2x, another negative 2x. We've got a positive 4. On the very end, if we are subtracting I squared, what does that become? Plus 1. Okay, I squared is negative 1. Negative I squared means subtract negative 1. Subtracting a negative means we are adding.
Wait,
Yes.
don't you, negative 2x minus 2x, that would equal negative 4x, right?
Yep, that's our next step. We combine our like terms. X squared minus 4x plus 5.
Oh, yeah.
But we're not quite done. What do we still need to do? The x plus 1. So we still have to double distribute the x plus 1. Do we have questions about what we've done so far? The x plus 1 part, that is straight review, so we shouldn't have too much trouble, but getting to this point, do we have questions? Those of you that are still with me. Okay. When we distribute x into that, good, x times x squared is x cubed. X times negative 4x, negative 4x squared, and x times 5 is a positive 5x. When we distribute a positive 1, does it change anything? No. So if you need to think about it one thing at a time, you can. Okay, but distributing a positive 1 keeps it as x squared minus 4x plus 5. It's not going to change the numbers or the signs. Last but not least, we combine our like terms one more time. X cubed combines with nothing. X cubed. Negative 4x squared and x squared.
Negative 3x squared.
Negative 3x squared. What about 5x and negative 4x?
X
A positive 1x plus 5
plus 5.
is just plus 5.
Oh, I get it.
There's our answer. What's your question?
So, so will the answer always have like x to the third and then x to the second power and then right?
Okay, that's a good question. We should all be listening and paying
Listen.
attention to it. So the question was, will it always be x cubed, x squared, x constant? So my answer would be if it's a third degree, you should definitely have an x cubed. It's possible that some of your other terms could cancel each other out somewhere along the way. Like at the very end here really is when that would probably happen.
Oh, like
Okay.
0?
Yeah, it's possible like you could have a negative 4x and a x squared and a positive 4x squared, and those would end up canceling at the very end. Okay. I wouldn't say that happens all the time, most of the time. It's just, it is a possibility.
It has to be so uniform. You just put 0.
If you want, you can put a 0 placeholder in, but you wouldn't have to. Yeah, the only time we have to have a 0 placeholder is when we're doing like synthetic division. Good questions. Also, if it says find a third degree polynomial and you come out with an x to the 4th, I would maybe take another look at it. Finally, which this didn't come up, so I'm hoping it means that we just understand this so well, but one thing that can happen sometimes is we're given these roots in the beginning, and we know we have to find another one. Okay, some people will want to tell me that positive 1 is also a root. Okay, rational roots do not have to come in pairs. Only if it's got a square root or an I does it have to have a conjugate pair that comes with it. Does that make sense? Okay, so just because it's got a single number without a root or an I Does not mean that it's always going to have a pair. It's possible it could. It's not always a thing. Okay. That is it for our note.